Hello, everybody. Welcome to OTC 2021. My name is Hussain. I'm going to be hosting this technical session. It's good to be seeing everybody coming back to normal activities. I know it was a tough year for all of you. I hope you all and your families have stayed safe. Our session today is about the coming age of artificial intelligence. The future is now. It's a hot topic, so I'm sure this, given the credential of our speaker, I'm sure you'll find this interview exquisite and highly informative. This will be a 60-minute discussion. We will try to accommodate some of the questions from the audience at the end of the session if we have not covered them already during the interview. So please line up your questions. If we cannot take them during the session, you can always follow up. We will post a link on LinkedIn with the interview, and you can follow up with these sessions. We'll cover them over there. Now, allow me to introduce our guest. Joining us today, Amir Husain. He's the CEO of Spark Cognition. Amir is a global pioneer, a thought leader, and a long-standing innovator in the AI space. He is also a passionate writer. He has written a brilliant book called The Sentient Machine, which talks about giving the power of perception to machines using AI and machine learning. His company is constantly innovating to provide AI solutions across many industries, government organizations, as well as in the private sector. Amir, welcome to OTC, and thank you very much for joining us today.
Thank you so much, Hussain. It's a great pleasure to be with you, and always wonderful to be at OTC, which is one of my mainstay conferences. And I look forward to a return back to normal when we can get to see each other in person. But thank you so much for hosting me.
Thank you very much. Amir, let me kick off this session by asking you briefly to give us a concise walk through the AI milestones that you think are worth highlighting. Many people from this session or join his session has come from different industries with different understanding of AI sphere.
Yeah, absolutely. So, Hussain, this is actually an older area of study than many people realize. Artificial intelligence officially was sort of, the kickoff conference was held at Dartmouth back in 1956 by John McCarthy, Marvin Minsky, Arthur Samuel, a number of other pioneers in the field. And the original expectation was that, they would achieve a lot of progress in the span of a short summer conference. And while famously, they didn't quite achieve as much real tangible progress in terms of building intelligent systems, it set the stage for the birth of a science, for the birth of artificial intelligence. And then very quickly, I mean, there's 4 or 5 things that I'll point out and tie these threads back together. In the early 60s, in 1962, I believe, Frank Rosenblatt worked on neurally inspired models. And he kind of reduced to practice the McCulloch-Pitts concept of how neurons in the brain work, and he implemented the system called a perceptron, which is in some sense the earliest form of a digital neural network, and that goes back to 1962. Then, of course, as artificial intelligence was being born, people like John McCarthy in particular started to look at logic as the engine with which machines would think. So predicate logic, going back to the Greek masters and implementing rules like modus tollens and modus ponens, if you remember your college logic classes, and reasoning in these sort of forward chaining logical systems. The Lisp language and the Prolog language, the development of both of these through the 60s, 70s, and 80s was really all premised on being able to do things sort of with logic. We also saw then search systems, so an algorithm that's still used for route finding, and it's very useful in many AI applications, called A-star. We were slowly building all of these capabilities. And then came, of course, the expert system revolution in the 80s. And this idea that we could encode large numbers of common sense facts as logic, and we would reason through them, applying forward chaining and propagation of these constructs to arrive at conclusions. The benefit of all of that, of course, was that you could see exactly how the machine was reasoning, in a sort of in a proper sense, step by step transition from fact A to conclusion C. How does that chain work? You could see that, and it was transparent. But the challenge with that expert system revolution was that the amount of facts that you had to encode in these systems was just way too large. There was a big project that was being run in Austin at the time, project called Psych, which went on for over 30 years, received a lot of funding from DARPA and others, but it never quite fulfilled the promise of having 10 million facts of common sense, as an example, encoded in a machine, and then providing a general purpose intelligence. So that whole thread, though, a lot of progress was made, and then we come to an age-old challenge in AI, which was chess, which for 2,000 plus years has been this has represented the epitome of human thought. Great strategic knowledge of the game is what allows you to win. And traditionally, we've thought that's a game really that a smart human can play. But then in 1996, IBM built their Deep Blue system, which very famously beat Garry Kasparov, who was the reigning world champion at the time. A few years later, in 2016, Lee Sedol, who was the reigning champion or one of the world greats in the game of Go, was beaten by AlphaGo. So, these are a few of the vignettes. But what I'd like to say in conclusion is a few things. One, AI has been around for a long time. And it's a very difficult field to sort of define, because the moment a computer system or an algorithm starts to solve a problem that previously only human beings could solve and was therefore considered a problem that requires smarts to solve, the moment a machine can do it, everyone turns around and says, well, this didn't require intelligence to begin with. For 2,000 years, we said chess was the epitome of intelligence and strategy. And then suddenly, after 1996, it was like, no big deal. We can, of course, chess, computer can play very well. So the field of artificial intelligence has these constantly changing, evolving targets. But the one target that has not changed is this aspiration, which I would say really goes back hundreds, thousands of years in the history of humanity, which is to be able to create at the level of a person, a machine that has the capacity, the thinking capacity, problem solving capacity of a person. And that goal is referred to as artificial general intelligence, where you can do general purpose work that requires cognitive complexity and goal seeking and problem solving to the level of a human individual. So of course we're far away from that, but the field of artificial intelligence has made a lot of progress. And the last point that I'll make is that across all of these kind of highlights that I shared with you, there's an approach or a view that what was being done in the 60s didn't work. Throw it away, move on to something else. Then what was being done in the 80s didn't work. Throw it away, move on to something else. But this is not my approach. I feel that there's a lot to gain from the search-based methodologies, the logic-based methodologies, these logic engines, which provide causal understanding. There's a lot to gain from large rule bases in particular domains. Now, the question is, how would you put together those large rule bases? Maybe we can automate some parts of that. And very famously, for connectionists, when the perceptron came out initially, few years after that, Marvin Minsky wrote the paper, a famous paper called On Perceptrons, where he said, perceptrons can't solve the most basic problems. And suddenly interest in connectionism fell until additional architectures evolved within that space that showed that, in fact, neural networks are a general purpose computational system. And so now with this deep learning revolution, we have perceptrons to thank for what got us still here. So I think a fusion of many of these techniques that I've highlighted are all relevant today. And what I enjoy most of all is architecting AI systems that bring elements of these together, bring more and more automation, but that, I don't like to do my work in a very sort of a fashion-driven way, where whatever the current fashion is, you just go whole hog behind that. I think there's a lot to learn from the history of AI, of which I've just shared, a few key developments and perhaps a short vignette of that history.
Awesome, Amir. Thank you for highlighting all these components. We are at the Offshore Technology Conference today, so could you shed a light on the use of AI for oil and gas business applications, and specifically what Spark Cognition is doing in that area as well?
Absolutely, Hussam. This is an area of deep interest to me. Energy is at the heart of society, heart of the world, and global stability is linked with energy. So when I founded Spark Cognition, my whole idea was to apply artificial intelligence to infrastructure, the stuff that makes the world go round, the stuff that runs the world, and energy is perhaps at the top of that list. What we are doing today is we've deployed our systems on offshore rigs, offshore oil rigs. Here, the challenges are, of course, reducing downtime, improving efficiency, improving output, etc., improving safety, reducing environmental challenges and risks. But the thing is that, in the past, people have taken statistical approaches, people have taken simplistic machine learning based approaches. But the reality is that a thing like an offshore oil rig, anywhere from 24 to 5 dozen subsystems all working together in concert, you can have situations where a statistical model or a machine learning model might predict for an asset, for one particular subsystem, the state of its health, and might say this is fine. And you might have similar nominal readings on a lot of other assets. But when you combine all of these unique things together, the emergent state, the emergent complexity of the interactions of many of these assets turn out to be harbingers of issues down the road. And some of our large clients, these are exactly the types of problems they were having. The current state of the art in predictive maintenance wasn't doing the job. And machine learning approaches were failing because of two reasons. One, they couldn't evolve models that were holistic enough to do an assessment at a macro level, at the rig level, and prevent downtime events. And the second challenge was that the implementing machine learning was incredibly expensive. You build the model, then the underlying equipment changes and shifts. These are rotating pieces of equipment, they physically change, and their behavior changes. So it's not just a question of retraining with new data. It's also a question of redesigning the underlying model. And the way that works is you bring people in again, you bring people with PhDs in machine learning that sit down and come up with the right model to use. But at Spark Cognition, we've pioneered this area of neuroevolution for application to industrial use cases. Neuroevolution has been around for a while. We've actually extended many of those algorithms, but then we've really pioneered the use of that technology in these industrial spaces. And so the cost of building new models, of maintaining large fleets of models, of really enabling an AI transformation powered by these models, we've brought that cost down. We've increased the speed with which you can deploy, and we've provided this kind of holistic view of large-scale assets, a refinery where we're also deployed, or offshore oil rigs where we're also deployed. But a few other things that I'd like to point out today. In fact, today it's a very important day for Spark Cognition. We just announced the acquisition of Ensemble Energy, which is a brilliant young company. They are focused on wind. They have a great platform for data acquisition and also asset management and tracking in the wind space, and they've got numerous customers in that space. Spark Cognition has been applying AI to that area as well. So now when we talk about large energy companies investing in transitions, we want to be at the cusp of that. We want to be taking the lead in enabling our valued partners to make that transition. And I think our investment in Ensemble and our acquisition of that company is one step. So I think there's a lot to do in those areas. A couple of years ago, we started working with leading automotive companies to assess battery capacity, battery predictive maintenance, battery life, battery optimization type problems. And we've built a significant technology in that area. And as grid and utility scale battery deployments all kind of fit in with this emerging picture of energy, that's another area where we have proven results. We've worked with great customers, and that's an area that we're taking forward. So what I would say is lots of applications in the conventional areas. Seismic analysis being another one. We're working with one of the large oil and gas majors in that area as well. So lots of applications for traditional oil and gas, with the added benefit of increasing efficiency, reducing environmental impact, reducing the chances of environmental disasters caused by unexpected failure of equipment, and then also creating these capabilities that help with the energy transition. Last point I'll make on that is, we have a joint venture with Boeing. Boeing is a tremendous partner for us, and we have a joint venture with them on the use of our AI platform, all of our products actually, embedded in this next generation aerial operating system, which provides autonomy for large numbers of drones. It provides monitoring. It interfaces with sensors. We also have a partnership with Raytheon. So we have a very holistic capability of being able to deploy drone fleets in large industrial contexts. So whether that is pipeline safety and security, using specialized sensors to detect pipeline leaks, automate the security of pipelines by using swarms of drones, inexpensive drones, whether it's sort of ship to rig delivery, ship to ship delivery, all of these types of applications. In other words, any large energy company, oil and gas company, whether for inspections, whether for deliveries, whether for security purposes, drones are now being used increasingly, and we provide the autonomy, the sensor analysis capabilities, the data fusion, the sensor fusion to enable those applications to be very valuable for our energy clients. So I spoke about a lot of things. There's a whole gamut of possibilities, and these are all the things that we're involved in.
Thank you, Amir. Very exciting. Having come from the energy industry myself, I'm very excited to hear more about this, and I'm sure a lot of what you mentioned will be changing the way we conduct services in this sector. So I'm going to move to security, which I want to touch a little bit on. Your firm is actively involved in some of the project with the DoD. You also just mentioned a minute ago your partnership with Boeing. So I'm sure a lot of these activities will be contributing to safeguard the national security. Could you shed a light a little bit about your company's involvement and advances in those two areas?
Yeah, Hussam, one thing for your audience, people that are interested in energy also have a good understanding of geopolitics, because energy and geopolitics have always been kind of enmeshed. So this is a special message that I share with your audience, which is that the world is changing. And in particular, in the defense sector, one of the big changes is that we are now in an era where we are moving away from platforms. In the past, military power has been defined by the number of aircraft carriers, the number of large leading aircraft, and so on and so forth. But in recent conflict, we've seen a couple of things. One, there's rising powers all over the world, and therefore the scope for conflict is diminished in terms of all-out conflict. And there are sort of these balances. The other issue is that advanced technology, commercial off-the-shelf technology, easily sourceable components, open source software, and indeed artificial intelligence have made it very easy and made it very fast to put together custom capabilities that have the ability to surprise. Swarms of all types integrated with sensors of different types, and the types of projectiles that can intelligently adjust course and defeat traditional defense mechanisms. So there's a burgeoning sense that the integration and the coming together of all these next generation technologies, many of which are exponential, is creating a fundamental challenge. And that our own DoD, as well as allied departments of defense, ministries of defense, have to take this into account. So the work that we're doing really 5 years ago, General John Allen, who's on our board of directors, also a dear friend and a colleague, he and I got together and we analyzed how artificial intelligence would change the future of defense. We eventually wrote a book called Hyperwar. And this whole idea of hyperwar is the convergence of AI and autonomy technologies and exponential technologies and their impact on the future of war. So moving away from the traditional platform thinking, making acquisition far more rapid to account for the technological change that's coming our way, and being able to rapidly construct custom capabilities with these essential building blocks of exponential technologies glued together by artificial intelligence. That seems to me to be the future direction in which this industry is evolving. And those are exactly the kinds of things that we focus on and work on. And not to get into too many specific details, but obviously the conventional work around predictive maintenance, prescriptive maintenance, being able to optimize systems better by using improved machine learning algorithms and automated model building. All of these things apply to defense equipment as well. But beyond this, there's a big shift coming. And that big shift is powered by these cognitive building blocks, these exponential technology building blocks. And the country, the force, the organization that masters the art of rapidly combining these capabilities on demand to create surprise in the battlefield, that will be the dominant force of the future.
Thank you very much, Amir. I know it's difficult considering the discretion of this information to be able to talk about that. So thank you for sharing what you said. So I have a confession to say. I'm a big fan of science fiction, and I've always been following on these spaceships, intelligent and sophisticated spaceships that is able to detect any failure that happens, heal itself, and help the spaceship commander with decision making. I keep asking myself if this is possible, and how are we going to evolve from having the AI gadgets that we have today that help us with different decisions into having a one global command center?
That's a very, very good question, Hussain. And I think there's two elements to that. One is a sort of a human and a societal element in which regulation and other such things fall in. And the other is a purely engineering element. And for now, allow me the liberty of just focusing in on the engineering and the science element. So I think in the history of the development of software, there have been some very interesting examples of philosophies that allow integration across a long span of time, across large numbers of people, and that components built and programs built 10 years apart, 15 years apart, suddenly magically, because of an adherence to a basic philosophy, end up all fitting together. And one of my favorite examples of this is the Unix philosophy, right? So Unix came out of really Bell Labs in the 70s, and there is a written down Unix philosophy. And as part of that, one of the tenets of that Unix philosophy is that do one thing and do it well. And when you're designing modules, when you're designing code, do one thing and do it well. Another piece of it is that every module, every program that you build should be able to talk to the other program. Now, when you focus in on that second element, the problem becomes, but programs do all sorts of different things. How can every program talk to every other program? And there are always exceptions, but for the most part, there's a huge collection of tools and utilities and systems within the Unix family, now Linux, and now Mac OS, OS 10, that all work together. And the amazing thing is these have been built over essentially the last 50 years, right? 50 years of developers and different styles, but yet they all kind of work together. On the command line, you can piece a program and add a pipe and add another program and add a redirect, and they all magically just keep working together. And the reason for it is because there's this essential concept at the heart of how all that works, which is sort of this very loose coupling. There aren't too many assumptions made on what one program will say and what the other program will expect. For the most part, it is unstructured text that is being exchanged between these programs, and they kind of all work. And across 50 years, hundreds of thousands of developers have put together code that you can build an application right now on the command line that takes something that was written in 1970 and combines it with something that was written in 2021. So I think a part of this challenge that you're proposing, which is how do we take individual systems of intelligence and make them all come together, make them all work together. There's two schools of thought. One is you build bigger and bigger systems of intelligence, and all the general purpose intelligence all happens within this one system, and that's a valid approach. You build a bigger and a bigger neural network, and there are people that I respect deeply. For example, Jeff Hinton recently said deep networks might be able to do everything. Now, you may agree with it, you may disagree with it, but it's a valid line of inquiry. And maybe one day there'll be very large deep networks that will do everything. But we know that that's not how, for example, the human brain does it. And we also know that planes don't fly in the way that birds fly. So there is no reason to emulate exactly how nature does things. The purpose is to achieve an outcome. So I think this loose coupled integration approach, which can be done today, we don't have to wait for some big breakthrough. We can start to take components and adhere to communication and interoperability guidelines that are very loose and allow a large number of these components to work together. If we were to have a Unix of AI, where a lot of these programs, a lot of these predictive modules could all be assembled very quickly on the command line or an equivalent infrastructure, then I think you could build tremendous systems where a lot of the capability that you want coming together could come together. And I will also tell you that for the last couple of years, this is not an announced product or a launched product, but for the last couple of years, I've turned my attention to this problem, and we've been working on this very deeply. And I do hope that before too much time goes by, you'll see the outcome and you'll see the output of this. But I'm very hopeful about this approach. I don't mean to suggest that by the end of it, you'll have, Cyberman becoming sentient, but that's not what we need, right? What we need right now is to solve complex problems and have information come together and have relatively general purpose frameworks that can take all of a domain or most of a domain and give us reasonable value. And I think there's viable ways to get there. And I'm very excited over the next few months to be able to share more on our work in that area.
Awesome, Amir. I'm excited myself to hear more about this when it happens. So there is a question about the give and take. There's a debate about the give and take as to what AI gives in terms and what it takes in terms of privacy. They're talking about these shops with overhead cameras, infused sensors, capturing everything we do, where we stand, which shelf we are at, what we pick, what we like, what we take away, and we are under constant surveillance. So a lot of personal data captured. So the question is, how are we going to rationalize the idea of comfort at the cost of privacy?
Hussam, many of your listeners may not like my answer, but I want to keep it very, very factual. The reality is that I think the ship has sailed. I think there are some things we can do to constrain companies' ability to collect technology and so on. And the large companies that will agree to be regulated and that have something to lose if you regulate them, they might comply. But really what the internet is and what these vastly connected networks of many types that we've created on top of the internet, what they are is a technological reality. And you can be an individual, you can be a large company. Regulation applies more to large companies because individuals are harder to find. Individuals can launch technologies and capabilities and platforms that you violate your privacy and use that data in nefarious ways. Nation states can do that as well. So, will a nation state be regulated by some other nation state's notion of privacy? Probably not. Will the internet be so bifurcated that you will never really come across the systems that this other nation state is deliberately implementing on this network to get information from you or to get an understanding of what you do? And this is just the digital layer. So the point is, to what extent can this even be achieved? Should we attempt to control it? Absolutely. We should look at regulation. We should take these large companies that are doing things which are far beyond what they need to do. We should try and constrain them. We should try and improve it. But the expectation should not be that we will win back our privacy. We're not going to win back our privacy in the way that we had privacy in the pre-digital age. The other element, which is something to think about, is how you protect your privacy through both knowledge and AI tools that defend you, protect you, and obfuscate what you do on the network. So in the Sentient Machine, in my book, there's a section on what I call AI shields and how you can use artificial intelligence to defend and protect you. And there are some really nefarious ways of targeting people individually, doing psychoanalyses automatically, and really, creating a very dangerous type of an attack directed at individuals. So you want to protect yourself from that, and how do you do that? And the last point that I'll make is that we are now living in a sensorized world that goes beyond just what goes beyond your interactions with websites or the internet alone. For example, when you can have a sub $1 sensor that can wirelessly transmit vibration, and you can have a $2 sensor that can take pixels and transmit them wirelessly, and you can have these all over the place, and you can have micro satellites that are flying all over. You can have small drones that develop 3D imagery. At any point in time, you're probably being watched by more sensors than you are aware of. And what you type on Facebook or Google or Amazon or on a Microsoft website isn't the end of it. It will probably soon not even be the most of it. So, in fact, one of my sort of theses is that we are now living in a world where just by existing, we are giving off tremendous signal. Because the world has become so smart around us that there are sensors everywhere. So it's really not what you do on a website. The question is, just by existing, you are giving off a signal. You're moving your car, some satellite is watching how frequently you're moving your car and is aggregating those metrics in traffic data predictions. You grow a crop, some satellite is looking at how your crop is doing to create an aggregated sense of what the total economic output of this crop will be by the end of the season. Many, many ways in which people are being looked at. And I think the ship has sailed. And I think what we now need to do is we need to define our core interests. What are the core interests around privacy that are absolutely inviolable for me? And I will support regulation around those. I will also educate myself around those, and I will finally equip myself around those. The responsibility of protecting ourselves partially falls to the state, but we know that our state isn't the only entity that can protect us, because the internet is a global system, satellites are a global system, RF emissions, and all of these things, they're not just controlled by one country. So we also have to take responsibility. The years ahead will require us to be a lot more savvy, a lot more technologically savvy, if we are interested in preserving our privacy.
Very interesting, Amir. I'm sure leaders such as yourself will have a big role in making these regulations, and I'm sure many people will adapt to these new standards as they come, of course. So I have a room for a couple of more questions. So before we move to the audience questions, so regarding the risks of AI, so can AI help us prevent a catastrophic outcome in the future, such as the COVID? I mean, we are still in the COVID, not out of it yet. So could you elaborate a little bit on that? Are we ready to take a next wave, and how?
Yes, I think more widespread use of AI can definitely help with pandemic outbreaks. There's repeated evidence of the fact that sometimes outlier events are reported by a human, sometimes on Twitter, sometimes in the traffic patterns of aircraft. And these, because they drown in this whole sea of data, they're not paid attention to individually. But certain algorithms can detect. So for example, the raid on the Osama bin Laden compound was first reported not by a news agency, but by a Twitter user who simply noticed that there were sounds of loud helicopters in the area at that point in time. And had there been a sensor that was attuned to interpreting the natural language that was put out on Twitter, then you would have had an early alert to that. With pandemics, we saw that there was some information that was shared, other information perhaps that was not shared on a timely basis. But there have been, flight pattern changes and so on and so forth. How can you use all of those to come up with a holistic assessment? That's the early stage. But then after that, artificial intelligence and its perceptive capabilities. For example, being able to couple AI algorithms with infrared and being able to identify patterns, body heat, etc., detect fever, and correlate that with other visible symptoms that would allow you to detect automatically whether somebody was suffering from a form of illness, perhaps COVID. Even with these ultraviolet-based germ eradication technologies, to be able to, in blue light, do pattern analysis using perceptive technologies, and then to be able to direct UV where it needs to go, and on a totally autonomous basis, ensure that there's instead of just the blanket coverage, there's very specific treatment of areas of infestation, and where impurities and germs, etc., reside. There's an unending, when you talk about isolating people and not having certain, don't come within 6 feet of another person in an open space. That's something that can be done with AI algorithms, either with a fixed camera over a field or with drones. You can watch and you can make sure that the patterns of interactions are being followed. Whether or not you use these technologies is a function of political will, of local desire, of what way a country leans and what structure people want around their lives. But my point is that the technology is available to help with a lot of these things. And AI also has a role to play, for example, in the actual discovery of drugs. So broad range of capabilities. I think investments in AI are probably some of the most effective and highest return in terms of what they can do, because you can do simple things with AI models and essentially package together a basic diagnostic, a basic doctor in a box. Now, that's not a full-on doctor, but somebody or a system that can do basic analysis and at least get enough data to give you a good picture of what's emerging in an area, some new kind of illness, some new kind of outbreak, on objective metrics as seen by the AI. So cheap sensors and these kinds of models can revolutionize healthcare, particularly in the pandemic outbreak context.
That is very good to know. Thank you very much, Amir. So I myself read your book, The Sentient Machine. I had a chance to read a few chapters before our interview, just to get a sense of your vision. So I know you're a visionary in that area. So could you give us a little bit about your predictions for AI for 2050 and beyond?
2050 is many years away, but I'll tell you one thing that I'm convinced of is that in a 30-year time period, the kind of change that we will see is very hard to specifically predict now, because we are at a time when multiple interacting technologies are all going exponential. So as an example, solar is now becoming the cheapest way to produce electricity. While there's been a lot of discussion around Moore's law, but nobody is saying that computers won't keep getting faster at a much higher rate. There's many different types of computing systems. Quantum is, I would say, from sort of useful mainstream apps, is maybe even decades away. Let's say it's decades away, but even that falls within the period of 2050. And then you have, obviously, space, which is becoming an area where more and more money is being invested. And space in two ways. One is exploration, which is longer term, and multiplanetary societies, etc., which is all longer term. But you also have near Earth orbit, low cost satellites, which are essentially an information product. And for the first time, companies, startups have the ability to access that resource, which was previously inaccessible to them. So when you talk about low cost satellites and you talk about really, really powerful edge processors, and you talk about, essentially tending to free electricity, and you talk about a $4, I mean, this year, a $4 microcontroller from the Raspberry Pi Foundation that can now run a Unix System 7, Fusix operating system. Who would have thought you could run Unix on a $4 microcontroller? But this is the world that we're living in, and in quantities of one, by the way. So that's another thing, which is that you don't need to be a very big player to get access to these technologies. So I think one prediction is the interplay of these exponential technologies will create massive surprise. I think within artificial intelligence, you'll find that we will begin to bridge the opaque deep learning type technology and some causal reasoning. So there are many architectures that are being proposed as to how you might do this, but I think that causality will become part of the picture. So AI will start to become a lot more explainable. I do think that deep learning, in terms of its resource consumption, is not scalable. Like, this can't go on forever. So there is a lot of effort in the community to make models that are as accurate as the best deep learning models, but to do so in much more lightweight ways. So I think lightweight AI is going to be another big area, and then we're going to see some big successes there, because there's no law of physics stopping us from achieving great results. And I've personally been part of projects and engagements where we've shown that this is quite possible. The other thing is, I think AI will take to the sky. And within the next decade, you'll see that we will move from a society that has thousands of manned aircraft in the sky to millions of unmanned systems in the sky. And that shift is not just about volume. It's about these new aircraft will be all shapes and sizes, very different to the manned aircraft era. And they'll do things which manned aircraft cannot do. They'll be very tactical, they'll be very task oriented. And then with these large numbers, you'll see that they'll also start to work together. And one area that we are investing in a lot is aerial terrestrial autonomy. So the idea that a robot can fly and it can be intelligent, and a robot can have terrestrial operations and it can be intelligent, and the two of them can solve problems together in many contexts, in many industrial contexts actually. So that kind of, you'll start to see robots that look very different, diverse teams of robots, all working together to solve big complex problems. And I think, again, I also look at some of the emerging sort of software stack. I think this whole idea on Ethereum and Cardano and a couple of other crypto platforms in producing decentralized computing and allowing decentralized applications to be deployed at scale. There's something there, and I feel that will continue to increase. I don't really care so much about what Ethereum is trading at today or yesterday or a week down the road. The real point is that there is a real need for a decentralized platform that aggregates compute in a democratic way and then furnishes that compute to run compelling, persistent, secure, private, protected, reliable applications. And that is a fundamental shift. And maybe that's a shift beyond the cloud. What does AI look like when it's deployed on a fabric like that? So, I mean, those are a few things. There's a ton more, but I want to be respectful of everyone's time.
I have many questions, really, Amir, but I'd like to leave some time for audience questions. So we will take some of those, and then if I have time to ask you more, I'll do that. So we have a question from Juan Bernardo Caballos. I think you you touch base on the positive regarding the expert system for predictive maintenance. So I think you mentioned that, but would you like to elaborate a little bit more on that? His question: what's Amir's position regarding expert system and predictive maintenance?
My position on expert systems is that for limited types of environments, it can work, but I've never really seen it work for any very complex environment. The reason being that very quickly you run into the unexpected interplay of things that you have not encoded as facts and predicates and clauses within that expert system. So you can find that for any reasonably complex problem, you have this sort of spiraling out of control of that system. It doesn't have the knowledge, and it's expensive to put that knowledge in. And in some sense, you're having to pre-think everything that can happen, or most things that can happen, at least the basic axioms. So in limited context, it can be useful. Juan, what I am fascinated by and focused on is the merger of systems of the type that you were discussing and deep learning, where the deep learning systems are focused on creating an understanding of some fact or some phenomenon. And then those are the multiple of those encapsulations of phenomena as identified by individual models are brought together within a causal reasoning framework. I think it makes the understandable, it becomes more understandable because the concepts are encoded in smaller networks, and they kind of all work together in a causal framework without you necessarily having to go out and encode every fact. So that's something that fascinates me. I do think that the science behind expert systems continues to be valid. You can learn a lot still by reading an AI book that was written in the 60s. In fact, I am reading an AI book that was written in the 60s right now. So I feel knowledge is never useless, but it's a question of how you adapt and how you apply.
Perfect. Thank you. Another question we have from Natalia Milovankina. I hope I pronounced the name right. It's about oil and gas. So she's asking why oil and gas companies are slow to adopt the use of AI products. You would think, with all the budget and huge financing they have, they would be fast. So she's asking, what does Spark Cognition plan to do to overcome it?
Look, the reality is that any large organization has its own inherent inertia. And there are different types of organizations. There are, for example, safety-driven organizations. And in order to be a safety-driven organization operating at the scale of 100,000, 200,000 people, there are some deliberate pieces, areas of friction. There are some deliberate checks and balances that are embedded throughout that process. Because this is a company that has to last for over 100 years. People will change. It's a company that delivers critical infrastructure, which can cause harm if it doesn't function well. So safety is a concern. The regulatory bodies are, honed in on these types of companies. So I can see why there's a lot of, relative, let's say, lack of speed in moving forward on these technologies compared to, let's say, the technology sector. However, I do believe that is changing. And I believe that the secret to changing it, your question on how does Spark Cognition plan to overcome it, the way to do that is C-level engagement. At the end of the day, artificial intelligence is not about solving a point problem. I've had many discussions with people who have welcomed us. We've begun a discussion and they've said, you know what, we've got this little side toy problem over here. Why don't you show us if we can? We're past that. We're not interested in that. We're not interested in the side toy problem that was solved many years ago, where it's been deployed over and over multiple times. And for that kind of effort, you kind of wonder what the organizational priority is. So one is, I think vendors have to be honest with their partners. Honesty is the basis of all of this. You have to be honest with C-level leadership, and you have to be honest with the people you engage with. We are well past the phase where there's some toy little engagement here, and can you validate that a neural network will find the pattern? Yes, the answer is yes, and I know that before even doing it. So the real question is, what's the meaningful problem that we can solve at an enterprise level? And that conversation is best had with leadership. How do you see the transformation of your company? And where all can artificial intelligence plug in to assist and augment that transition? If you are aligned on that, then some things will go well, other things might not go well. But this is the nature of any large, complex human run project, and any big technology transformation. But you're committed to the outcome, and you know that that is something you will achieve under all circumstances. That shared understanding, that shared ownership of an outcome, that's the way to do it.
Thank you very much, Amir. So we have one more questions from Hani Shahawi. So says, Amir, regarding the shift from platforms to more flexible and adaptive sets of capabilities joined by AI, does that apply to the software platforms as well, e.g. platforms marketed as enterprise AI?
Honey, I think this is a big shift. I think that being able to, look, in software engineering, component reuse, reusability, all of these concepts have been around for a long time. The thing is that as you make components that are becoming more and more sophisticated, how do you allow them to generically communicate with each other? It's a new kind of a challenge in terms of its specifics. But in terms of the broad concept, the concept is Lego blocks, right? Lego blocks of all shapes and sizes combining together, and there's an infinite set of possibilities that can result from that. So I do believe that this approach of taking models that are able to talk to each other very quickly and creating cognitive pipelines. I've delivered a number of talks on this. I've written extensively on Forbes and other places, what I call the model-driven enterprise. Three types of models: perception, decision, and action. And to take perception-driven models, have a library of them, and hopefully you have those auto-evolved. By using a platform like Spark Cognition's Darwin, you don't even need to write the code. Those models get built up automatically, and then you recombine all of these to create enterprise flows that solve problems. So this is a big topic, but I would recommend that you look at my work on model-driven enterprises, and in particular, this kind of neuroevolutionary powered generation of models, which allows you to generate these models quickly and also maintain them over time automatically and at low cost.
Thank you, Amir. Some of the questions are regarding the implementation of oil and gas sector between domain. So I think some of the other questions were covered partially during the interview. So I will take the chance to ask a question myself. So we all heard about the controversy surrounding the potential foreign intervention with the US elections. Can AI be used to execute mind-hacking activities to change the outcome of the elections? And how can that happen, and how do we guard against such things?
This is probably one of the most important questions of our time. There's two or three levels at which this activity is happening. One is the most overt, right? Which is that somebody literally hacks into a voting machine and starts to change things up. What is the impact of that? I'm not sure. There's been lots of different opinions, but is it possible? Sure. I mean, it's a computer system. Is it possible to hack a system like that? Yes. Big systems have been hacked over and over and over again. The second part is that, okay, but what outside of that can someone do? The real danger is that we are now living in a world where you can change people's opinions in large numbers. And some would argue that, but you could do that previously also. You could, you had propaganda on TV and so on. Yes, but not everyone in the US was, for example, listening to propaganda coming from outside the US. And not everyone outside the US was listening to the US's version of events. Now with the internet, everyone is listening to everything. And people are self-selecting themselves into preferences. Now, in addition to this, people are also expressing opinions. When they express opinions, they give off themselves to the internet. Now your dialogue, your sentences are now captured for somebody else to analyze. And there are automated techniques, for example, the ocean model, which uses just written text by an individual and algorithmically gauges whether somebody is neurotic or extroverted or various different aspects of personality. And if you are neurotic about a topic, then maybe the way to push you over the edge individually is to start targeting you with campaigns and words and topics and pictures that are literally going to drive you over the edge on a topic. So the difference now is that it's not about mass propaganda. It's about really intelligent, targeted propaganda executed at scale, where the computational and algorithmic complexity is such that you can target individuals. You can learn about them, build profiles about them, and then come after them and change their mind. That to me, we are in the early stages of, but that to me is a real risk. In the US, we had a few years ago a major hack where the Office of Personnel Management, which maintains, I think for the last 10 years, every single security clearance file, which is who the individual is, where they've worked, what they've done, how much they make, their spouse, their family, everything about them, what they need to do a security clearance. All of that is part of the OPM records, and all of them were hacked over a period of 10 years. So imagine the amount of data that someone, some bad actor, has on millions of US citizens, to the point where they themselves probably don't remember that much information about themselves. And so with a trove like that, what type of targeted models could you build to affect people in nuanced ways? So this art of the highly personalized cyber campaign running at scale, that to me is a nuclear threat as far as stability of societies go. And I don't think that anybody has executed a threat like that, but I'm quite convinced that there's a lot of people that are building the technology to be able to do things like that. So if that's the case, then it's time to invest in defenses. And like I said, going back to the earlier question, part of that is the government. And as you saw with President Biden's speech about the colonial pipeline hack, part of that is us. We need to, as companies, as individuals, first educate ourselves, learn, be skilled, and be prepared with the right tools to defend ourselves. And this is just the reality of the world.
Thank you, Amir. Very logical. It seems like these levels of threats and risks will push us to the edge and to be more prepared to handle these risks. And the AI will be the vehicle to do this. So I think we've come to the end. We have one more minute of our interview, so I will conclude here. Just wanted to thank a few people who are working behind the scene, Asha and Jamie, for making this live broadcast happen. Thanking the audience for all their valuable questions. And as I said, we will have follow up on more questions on LinkedIn, where this interview will be posted, as well as on YouTube. So follow up will happen there if you have more questions. I'd like to thank you, Amir Husain, for this wonderful interview. We were privileged to have you today in the OTC. And thank you very much for dedicating the time to join me.
Thank you so much, Hussain. Thank you to the audience. Would love to continue the dialogue on LinkedIn and continue building the future with you all.
Thank you very much. And we adjourn here. Thank you.
Thank you. All the best.